Aston Martin just pulled off one of the boldest moves before race 1, and it could either revive their entire season or expose a flaw that changes everything. Just weeks ago, the AMR26 was seconds off the pace in pre-season testing. Minimal mileage, power turned down, and a vibration issue so severe it was physically damaging the Honda battery system. That is not a small setback. That is a structural crisis heading into a brand new regulation era. But now, ahead of the Australian Grand Prix, Aston Martin has arrived with major Honda engine upgrades, reinforced battery architecture, reworked hybrid deployment maps, a redesigned cooling concept that literally changes how the car breathes under full load. This is not a tweak. This is a first race intervention under maximum pressure. 300 kilometers in Melbourne. Full throttle. Full energy deployment. No hiding behind test programs anymore. If these upgrades work, Aston Martin unlocks the true potential of one of the most radical cars on the grid. If they fail, the entire new Honda partnership starts under immediate and very public doubt. And what makes this even bigger is that Australia is not just race 1. It is the first full stress test of a project that already showed cracks. Subscribe now, because what happens in Melbourne could define this entire season before it even begins. Let's break down exactly what went wrong in Bahrain. Because on the surface, it just looked slow. Aston Martin near the bottom of the timing sheets. Minimal long runs. And an AMR26 that never truly looked comfortable. But behind those lap times, something far more serious was happening. Honda officially admitted that the pre-season program had been extremely challenging due to a combination of abnormal V6 vibrations and high-voltage battery damage. That is not minor calibration work. That is structural stress inside the hybrid system. In specific engine rev ranges, the vibration frequencies lined up with natural resonance modes within the chassis and battery mounting structure. When that happens, energy does not dissipate smoothly. It amplifies. Internal components begin to suffer. Micro-damage builds. And temperature rises faster than expected. At one point, telemetry indicated the battery was entering a critical thermal zone, forcing the team to shut the car down immediately. No dramatic final run. No risk taken. Just stop. And here is the key detail most people missed. The issue was not isolated to one faulty battery. It repeated across different units. That confirmed it was systemic. An integration problem between engine, hybrid system, and the extreme packaging of the AMR26. Now think about that. Adrian Newey designed this car with ultra-tight bodywork, minimal cooling volume, a very aggressive aerodynamic concept. In theory, that delivers incredible efficiency. In practice, it leaves very little margin for error. When vibration and heat combine, there is nowhere for the stress to escape. During aggressive energy charge and discharge cycles, temperature spikes became so severe that Honda had to significantly reduce power output during longer runs. Which explains the visible straight-line deficit in Bahrain. The engine was not weak. It was restrained, running below its intended performance ceiling to prevent further internal damage. That is why pre-season numbers can be misleading. We did not see the true AMR26. We saw a protected version. A car operating inside a narrowed safety window. And that is exactly why Australia matters so much. Because the major upgrades brought to Melbourne are not about adding horsepower. They are about widening that operating window. Stabilizing the hybrid system. Reducing destructive vibration transfer. Allowing the power unit to run closer to its real potential without fear of thermal escalation. If that window opens successfully, then everything we saw in Bahrain becomes context, not destiny. So what exactly did Aston Martin and Honda change for Australia? This is where the response becomes serious. Because they did not try to hide the weakness. They attacked it directly. First, the battery mounting structure. Engineers worked on reinforcing and redesigning the way the battery is supported inside the chassis, specifically to reduce how vibration energy transfers from the V6 into the battery casing. That may sound subtle. It is not. In a modern Formula 1 car, the battery is exposed to constant mechanical and thermal stress. If vibration is not absorbed at the mounting level, it travels through the chassis, into the electronics. And once internal damage begins, performance drops fast. Honda even began replicating the issue in controlled bench testing, mounting the battery to a chassis structure to reproduce the exact resonance pattern seen in Bahrain. That tells you this was not guesswork. It was measured engineering under pressure. Second, the hybrid deployment strategy. The ERS maps have been revised to smooth out torque delivery, especially in engine ranges where vibration harmonics were most aggressive. Less sudden electrical spikes. More progressive energy release. Stricter limits on charge and discharge cycles per lap. Yes, that may slightly reduce the explosive feel out of slower corners, but it dramatically lowers stress on the battery cells across a full race distance. And over 300 kilometers, that matters far more than a single qualifying lap. Then comes cooling. During testing, Aston Martin literally opened additional ventilation outlets to help manage temperature. For Melbourne, that philosophy continues. More airflow, less extreme compression around the power unit, a slightly more open rear body configuration to allow heat to escape more efficiently. Of course, there is a trade-off. More cooling usually means more drag. More drag can reduce peak straight-line efficiency. But here is the difference. In Bahrain, they were slow because they were forced to protect the engine. In Australia, they are choosing stability first. That is a controlled compromise, not a desperate reaction. And internally, the objective for Melbourne is clear. Finish the race. Complete the full 300-kilometer distance without destructive vibration cycles. That is the real benchmark. Because once the system proves it can survive race conditions, development accelerates immediately. Honda can gradually reintroduce more aggressive deployment. Nui can refine the aero concept without risking thermal overload. The entire project shifts from survival mode to controlled evolution. But if instability resurfaces under race stress, if vibration signatures reappear at high fuel loads, if battery temperatures climb unexpectedly, then the conversation becomes much more uncomfortable. Because that would suggest the issue runs deeper than mounting reinforcements and mapping changes. That is why Australia feels so critical. Not because it decides the championship, but because it reveals whether the AMR26 is fragile, or finally ready to operate the way it was designed to. Now let's go even deeper. Because this is not just about fixing a vibration issue. It is about protecting the entire philosophy behind the AMR26. Adrian Newey did not design this car to be conservative. He designed it to be extreme. Ultra-tight packaging, aggressive airflow management, minimal tolerance for thermal inefficiency. That kind of concept can deliver huge aerodynamic gains. But it also creates a very narrow operating window. In Bahrain, that window proved too narrow. The engine vibrations did not just stay inside the power unit. They interacted with the chassis. They amplified through the battery supports. And the hybrid system paid the price. So Australia is not simply a race weekend. It is the first test of whether this radical concept can be stabilized without losing its identity. Because if the reinforced battery architecture successfully absorbs vibration, if the revised ERS maps prevent destructive energy spikes, if the expanded cooling layout maintains stable temperatures over a full stint, then the entire trajectory of the season changes. Why? Because once stability is proven, performance can be layered back in. Power can be increased gradually. Deployment windows can be widened. Cooling apertures can be optimized instead of oversized. Aero balance can be refined without fear of suffocating the engine. Everything compounds. But here is the uncomfortable branch of this story. What if race conditions expose something the bench tests did not? High fuel loads change vibration characteristics. Safety car restarts demand sudden maximum deployment. Dirty air reduces cooling efficiency. These are real variables. If the system shows even small signs of instability under those conditions, Honda will have to return to protection mode. More conservative maps. More restricted power. More drag-heavy cooling configurations. And in a development race, time spent stabilizing is time not spent gaining performance. This is why insiders are treating Melbourne as a proof of integration weekend, not a proof of speed weekend. Because the AMR26 does show aerodynamic promise. Onboard footage during reduced power runs suggested a stable high-speed platform. That means the chassis may have genuine development headroom. But none of that matters if the hybrid system cannot operate reliably. And there is another strategic angle. Under current regulations, manufacturers who begin the cycle behind may gain additional development flexibility. If Honda stabilizes early and then leverages that flexibility, they could improve at a faster rate than teams that already appear comfortable. Short-term embarrassment. Long-term opportunity. But that opportunity only exists if Australia proves the foundation is solid. Because once a platform is structurally stable, confidence spreads. Drivers push harder. Engineers take calculated risks. Upgrades become aggressive rather than defensive. Momentum builds. And in Formula One, momentum is everything. So when the lights go out in Melbourne, this is not just the first race of a new season. It is the moment that reveals whether Aston Martin's bold response to a structural flaw was enough. Whether Honda's reinforced architecture truly solved the resonance problem. Whether the AMR26 can finally run at the level it was designed for. If it can, the shock will not be that Aston Martin survived. The shock will be how quickly they start climbing. And if it cannot, the questions will only grow louder. Either way, Australia is not just race 1. It is the defining stress test of an ambitious partnership that has already shown both fragility and enormous potential. And now we arrive at the part that truly defines this story. Because Australia will not just reveal whether the upgrades work. It will reveal whether Aston Martin understood the root of the problem. There is a massive difference between treating a symptom and correcting a structural flaw. In Bahrain, the symptom was obvious. Low top speed. Interrupted long runs. A car that looked hesitant instead of aggressive. But the root cause was deeper. A vibration coupling issue between the V6, the hybrid system, and the extreme packaging of the chassis. If that coupling has been neutralized, even partially, then what we are about to witness could surprise a lot of people. Because here is what changes when stability returns. Drivers can trust deployment. They can attack corner exits without fearing sudden derating. Engineers can push setup toward performance instead of safety margins. Strategists can plan aggressively instead of defensively. Everything becomes sharper. And this is where the psychological shift matters. Fernando Alonso has experienced unstable projects before. He knows when a car feels restricted. If he feels consistent power delivery over an entire race stint in Melbourne, that alone changes the internal tone of the team. Confidence spreads quickly in Formula 1. But doubt spreads even faster. That is why this weekend carries so much weight. Not because Aston Martin is expected to dominate, but because the car must demonstrate composure under stress. Look at the specific moments that will matter. The race start. Maximum torque. Full deployment. Heavy fuel load. If the hybrid system remains smooth there, that is a strong signal. Safety car restarts. Sudden acceleration after slow laps, when temperature balance shifts. If the battery remains stable in those moments, that is another signal. The final 10 laps. When temperatures peak and fatigue sets in. If power delivery remains consistent then, that is the clearest confirmation of all. Because the objective is not peak lap time. It is sustained stability across 300 kilometers. And if that objective is achieved, the implications are enormous. Once a platform proves durable, development accelerates. Honda can begin increasing deployment margins step by step. Cooling apertures can be refined for efficiency instead of oversized for safety. The car's aerodynamic potential can finally be explored properly. The AMR26 stops being a fragile prototype and becomes a foundation. But if instability returns, even in subtle form, everything slows. More conservative maps. More thermal compromises. More development time lost to integration fixes. And in a tight field, lost time is lost opportunity. So when people say Aston Martin shocked everyone with these Honda upgrades, the shock is not about immediate lap time. It is about boldness. They admitted the flaw. They reinforced the architecture. They widened the operating window before chasing performance. That is a strategic decision, not a cosmetic one. Australia will now answer the only question that matters. Is this project fragile under pressure? Or is it stronger because of the pressure it has already survived? And once we see the AMR26 complete its first full race distance of the season, we will know whether the shock was temporary, or the beginning of something far more dangerous for the rest of the grid.